So welcome you all for the online classes. We are discussing the chapter electromagnetic induction. So last class we started mutual inductance. Once again, for last class we are not dictated notes. So for the purpose of that notes, so I will write few points on the board. So who's required that mutual inductance, so you can note down. And this topic is why I am repeating once again means. So this today topic related with this mutual induction only. So what is mutual induction? In this mutual induction, last class we have seen the mutual inductance of two long coaxial solenoids. Instead of coil to take as a solenoid, we can take a coil. So let me take the two coils. So this is one coil and this is another coil. So one coil connected across galvanometer I will call primary, and which coil connected across the current that is secondary. What is mutual induction? Mutual induction is a phenomena. It is the phenomena. The phenomena of what? So developing induced EMF in one coil due to change of current in another coil. In which coil? In another coil. So this is the definition for mutual induction. See, primary and secondary coils both are not interrelated with, both are not in contact with each other. So though when you close the plugging of the secondary coil, the current in the primary coil start increasing. Because of that current, magnetic field value changes, which is in coupled with the primary. So then what happens? The galvanometer shows deflection. When galvanometer shows deflection, when developed some induced EMF and induced current will flow. So the phenomena of developing induced EMF in one coil due to the change of current in another coil, that phenomena name is called as what? Mutual induction. It's very important phenomena. The transformer, extra you will get in AC currents. The working principle of transformer is mutual induction only. Now, on what factors the flux linked with the coil? Primary coil. Can I call phi 1? So depends upon the flux linked with the primary coil. Depends upon the current passing through secondary. Can I call the primary coil flux value phi 1 and current through secondary can I call I2? Even I can also write the primary coil as IP, the secondary coil as IS. It is very clear. Flux linked with the primary coil is directly proportional to current passing through secondary coil. To remove the proportionality, so M12 into which one now? So IS. What is the name of M12? M12 is the coefficient of what is M12 name? So M12 is the coefficient of mutual induction. Coefficient of mutual inductance or induction, or simply it is also called as mutual inductance. Mutual inductance of which coil? Mutual inductance of, can I call the first coil name of primary coil? Primary coil with respect to secondary coil. With respect to secondary coil. Are you getting that? The name of M12 is the coefficient of mutual induction or mutual inductance of primary coil with respect to secondary coil. We can define in one more way also, according to which law? According to the Faraday law. According to Faraday's laws of electromagnetic induction. Faraday's 10 laws you will get. So in chemistry also, that's why you need to mention. According to the Faraday law of EMI, the induced EMF magnitude value will be equal to d phi by dt. Induced EMF developing in which coil? Primary coil. So is d phi p by dt. Can I substitute the value of phi p? So phi b, if I substitute, so modulus of E value will become d by dt of phi b value. So m12 into is. Okay now. So these two formulas I will use for defining the coefficient of mutual induction or the mutual inductance. Mutual inductance definition. So I will define in two number of ways. You can write any one definition. What is the definition 1? To write the definition 1, so I will consider the equation. The flux linked with the primary coil is M12 into Is. So from this, M12 will be equal to phi p divided by Is. If Is value is equal to 1 ampere, then what happened to M12? M12 value is phi p. Because we showed last time M12 value, M21 value both are same. So can I write this simply as M? If I write it as simply M, so here also I will write M. So here also I will write M. Therefore, the mutual inductance of a coil numerically equal to flux linked with the coil due to the passage of 1 ampere current in another coil. So because of 1 ampere current in one coil, but remember, so in this coil the flux should change. To make the flux to change, there are many methods are there. The current, a steady current of 1 ampere passing through secondary coil. When you move the secondary coil towards the primary, flux changes with the primary coil, develop induced EMF. So okay now, so when you are not fixing the secondary coil, the secondary coil can move either towards the primary or move away from the primary. It carrying a current of 1 ampere. How much flux linked with the primary coil? That is numerically equal to, so coefficient of mutual inductance of primary coil with respect to secondary coil. So there is one more definition I told you now. So what is that definition? We can define definition 2. To define this, I will take E, modulus of E is equal to, so simply can I write M1. So what is d by dt of M into I? Since M is constant, so I can put M value outside, or E is equal to modulus of E, M into di by dt or dis by dt, current through secondary coil. From this, M value is modulus of E divided by dis by dt. Correct? If whenever dis by dt is equal to 1 ampere per second, then what happened to M? So M value equal to modulus of E. Can I write here? So then what happened to M? M value numerically equal to, if ds by dt, then M value is equal to modulus of E. Okay now? What is the second definition? The induced EMF. Here I will write. If you want the definition, those cannot see that, I will write here. So if which one? dis by dt is equal to 1 ampere per second, then what happened to M is equal to E. What does it mean? The mutual inductance is numerically equal to the induced EMF developed in which coil? Primary coil, due to the rate of change of current of 1 ampere per second in which coil? So secondary coil. In secondary coil, if the current is changing 1 ampere per second, how much induced EMF developed in primary coil? So that is called as coefficient of mutual inductance. Correct? So this is what we discussed in last class. Only for writing the notes purpose. So I repeated once again, and that day already written units. So SI units are given by Weber by ampere. The Weber by ampere is nothing but a Henry. And also we have seen the coefficient of, so two long coaxial solenoids. So expression given by mutual inductance of two long coaxial solenoids, M value mu naught into N1 into N2 into pi into R square into L. Expression for mutual inductance of two long coaxial solenoids. So what are the factors on which M depends? The mutual inductance of two long coaxial solenoids, it depends upon which factors? It depends upon geometry of the coil. Which one? The geometry. Geometry in the sense, so it depends upon the number of turns, it depends upon the radius, it depends upon the length. But remember here, R is the effective length, effective radius, the radius which is common for both, and it depends upon the medium. It depends upon the medium between the coils. So these are the factors on which the mutual inductance depends. Mutual inductance, very important topic. Based on the mutual inductance, there are 2-3 marks questions can be asked. One question is define mutual inductance, write down the units and dimensional formula and define the coefficient of mutual inductance. One more question is, so obtain the expression for mutual inductance of two long coaxial solenoids. Even that question can be also asked for either 3 marks or 5 marks. Maximum 90%. 5 marks questions are not asking from this chapter. So if the question given for 3 marks, so if you derive only for one coil, so if you write the similarly for another coil, enough. Okay, Nara? So this is for mutual inductance. Now we will discuss today's topic. This is, so that is self-induction. So what is self-induction? Before defining this, first let us see, considering one coil with a number of turns, coil connected across a battery with a plug. So initially plug key was open. Now when plug key closed, when plug key closed at a time t is equal to 0, so what is the initial current in the coil? Initial current in the coil is 0, right? There is no coil current at a time t is 0 when plug key was closed. But after a time t, the maximum current in the coil, so can I call I0? What is the initial current in the coil? 0. What is the maximum current in the coil? Is I0. Now what happened? For this current to increase from 0 to maximum, does the current increases instantaneously? But this is not an instantaneous process. In order to increase the current, the coil opposes the growth of current. Why the coil opposes the growth? Let you know. Now when current in the coil is increasing, so what happens? Flux will increase the coil. When current is passing in the coil, around this coil what will be the magnetic field will be? That is in the form of field lines. According to magnetic effect of electric current, so magnetic field will be. Right, Ara? Now what happened? The magnetic field is measured in terms of field lines or magnetic flux. When current increases in the coil, the flux linked with the coil will be increases. Then according to which phenomena? Electromagnetic induction. So what will develop? The induced EMF will develop. Induced EMF will develop. There is one more name for this induced EMF, is also called as back EMF. Why it is called as back EMF we don't know. So induced EMF will develop. In what direction it will develop? It is developing a direction opposite to the cause of it. Are you getting clearly what I am telling, writing on the board also simultaneously? So then what happened now? Till now I have not discussed the definition for self-induction. I will tell when to write the definition. So now here what happened is, when plug key was closed, the current value increasing from 0 to maximum. Due to the change of current, so flux linked in the coil will be increasing, developing EMF, and because of the EMI, induced EMF or back EMF will develop, which opposes the cause of it. So means what happens? The induced EMF will develop in a coil. It does not allow the current to increase. So it opposing the current, that's why it is also called as back EMF. Okay. Now what I decided? So what is the conclusion I made? Coil is not allowing the current to increase instantaneously. But finally, because of the battery doing some work, the coil will allow so current to increase. But battery has to do some work. That work done will store in the form of potential energy. That is important derivation. So we will discuss. Now what I decided, so after increasing the current to maximum when plug key was open, I opened the plug key. At a time when plug key was open, at t is equal to 0. So what is the maximum current? At a time t is 0 when plug key was open, maximum current in the coil is how much? Is I0. Now after a time t, so what is the final current in the coil? Finally the current in the coil should become 0. Now the question is, does the current reaching from maximum to 0 instantaneously? So when plug key was open, so current in the coil start decrease. When current in the coil start decrease, what happened to the magnetic flux linked with the coil? So magnetic flux linked with the coil decreases. Because of the EMI phenomena, again induced EMF will develop. In a direction opposite to its own cause. What is the cause here? So decreasing of current. That's why the coil will not allow current to decrease. Are you getting it? Coil is not allowing the current to increase and not allowing the current to decrease because of the developed induced EMF. Are you getting it? So coil opposing the change of current. This property is similar to that of in mechanics. In mechanics, nothing to write till now. Just listen only. In mechanics, we know inertia. So what is inertia? The property of the body. So due to which the body so opposes to change in its state of rest or state of motion or state of direction. The body at rest, you don't want to come to motion. The body in motion, you don't want to come to rest. Here coil not allowing the current to increase, the coil not allowing the current to decrease. So coil also having some property, the property of inertia. But inertia here, so what is the measure of inertia? So mass. Mass is the measure of inertia. So measure of inertia. Inertia is measured by mass. Here, so self-inductance or inductance of a coil. There is one particular name. So that is called as inductance, represented by the symbol L. This inductance will play the role like inertia. Like a inertia. This inertia is called as electrical inertia. Which inertia? Electrical inertia. Mass is the measurement of mechanical inertia. Inductance is the measurement of which one? Electrical inertia. What is inductance? Now we will discuss. For defining that inductance, first let me define. So what is mutual self-induction? Important definition. So self-induction topic is very important. Based on this, we will get the 3 questions are there for 3 marks. This class we will discuss on 2 questions. So for 3 marks, what is self-induction? So you can write down along with the listening. It is the phenomenon of developing induced EMF in a coil due to change of current in the same coil. Change of current in the same coil. Are you getting it? Because of the change of current in the same coil, the induced EMF developing. It is the phenomena of what are developing. Which one? Induced EMF. Where does it induced EMF developing? In a coil. But when does that induced EMF develop? Due to the change of current in the same coil. So what is the major difference between the self-inductance and mutual induction? In self-induction we consider 2 coils. One is a primary and other is a secondary. So because of the change of current in secondary coil, EMF developing in which coil? Primary coil. That is for which one? Mutual induction. Mutual. Because of one developing in another. Now here the name is self. Because of the changing the current in the same coil, induced EMF developing in the same coil. Are you getting a definition okay now? What is the definition for a self-induction? It is a phenomena of developing induced EMF in a coil due to change of current in the same coil. Okay, Nara? Now you tell me. So flux linked with the coil. Here no need of writing primary, secondary. Only one. The flux linked with the coil is directly proportional to current passing through the coil. To remove the proportionality, we needed one constant. That constant was given by L. What is the name of L given by? So L is called as coefficient of self-induction. Coefficient of which one? Self-induction. Or it is also called as self-inductance or inductance of a coil. Self-inductance or inductance of a coil. Generally, inductance means it will come for both. M also inductance, L also inductance. Single coil is there means you can write L. If two coils are there means you can write L. Okay, now. So before going to definition, so what is the definition for which one? So self-inductance or the inductance of a coil. I want to define inductance of a coil. So definition before telling, we know according to Faraday laws of EMI. Same what are the methods and we studied for mutual induction, same we study for self-induction. According to which one? Faraday's laws of EMI, electromagnetic induction. So what we know, the induced EMF is d phi by dt. Can I substitute the value of phi, which implies so modulus of E d by dt of phi value L into I. Since L value constant, the modulus of E is equal to L into di by dt. If mutual inductance is understood means self-induction is very simple or very easy to understand. Now what is the definition? So to define first definition, first method means you can define any method. So first one I will give you the definition. According to phi is equal to L into I. So what is the value of L? Phi divided by L. So if I is equal to 1 ampere, then what happened to L? L value equal to phi. So what does it mean? The self-inductance, or I can write inductance or self-inductance. The self-inductance of a coil numerically equal to flux linked with the coil due to the passage of how much current? 1 ampere current. If 1 ampere current passing from where to where? 0 to maximum. Due to the passage of 1 ampere current, how much flux linked with the coil? So that is called as self-inductance of the coil or inductance of the coil. Next one is the second definition. So according to this one, what is the formula for induced EMF? E is equal to L into di by dt. From this L is equal to E divided by di by dt. If di by dt will be equal to 1 ampere per second, then what happened to L? L value numerically equal to E. But remember, to develop the induced EMF, what should change? Current should change. If the current rate of change of current is 1 unit per second or 1 ampere per second, 1 ampere current flowing per second, then how much induced EMF developed in a coil? That is numerically equal to the inductance of the coil. So that is numerically equal to inductance. So two definitions are there. The definition for self-inductance and mutual inductance, same definition. Induction different to inductance different. Are you getting it? So self-inductance of a coil, even general definition you can define. The self-inductance of a coil. So what is the self-induction inductance of a induction of a coil is, it is a property of the coil due to which the coil opposes the growth of current or change of current in the same coil. Are you getting it? So that is called as self-induction. Okay. Now what are the units and units and dimensional formula of this self-inductance? So SI unit, same. SI unit of phi is equal to L into I. Then L value is equal to phi divided by I. Phi SI unit is Weber by CGS unit is ampere. This Weber by ampere has some particular name. So that is given by Henry. Even dimensional formula also same. Okay now. So till now the question what we discussed for, that is 3 marks. Define the self induction, write down the unit cell and dimension formula, and write down the define the coefficient of self induction. But remember the inductance of a coil or the self inductance of a coil. The inductance of a coil will play the role of which one? So inductance is called as what? Inductance is so known as electrical inertia. It will play the role. It is also called as electrical inertia. Which is the measurement of electrical inertia? Inductance. If the inductance value more means the property of opposition is more. If the inductance value will be less means the property of opposition is less. Now we will see. So expression for self inductance of a long solenoid, current carrying solenoid. Okay Nara? So next question. This is the last topic for this class. So expression for self inductance of a long, compulsory condition is long current carrying solenoid. Someone will pronounce this as solenoid, someone will call solenoid. So pronunciation you don't bother that much. Solenoid is solenoid. So long solenoid. Last class we have derived so important derivation for 3 marks. We have seen 2 long coaxial solenoids. Here no need of 2, only 1 is enough. Let me consider one long solenoid with the number of turns. This is one solenoid. This is the axis of the solenoid. The length of the solenoid let me call L, and radius of the solenoid let me call R. This solenoid is carrying a current I. When you are writing a derivation, compulsory you need to write the description. The description not given means, not written means you will not get full marks. Let us consider a solenoid of length. So what is the length of solenoid? So length or directly I will write the length of the solenoid is L. So total number of turns. How many turns are there in this solenoid? Let me call N. And current carrying. The solenoid is carrying a current. Let me call it as I. And this solenoid radius value, the radius of solenoid let me call R. The next number of turns per unit length. This is important one. So number of turns per unit length. Per 1 unit length, how many number of turns are there? So that is given by capital N, small n. This small n value is equal to capital N divided by L. Okay Nala? This is the description. Consider a solenoid of length L carrying a current I, radius R, total number of turns N, number of turns per unit length is this much. Now what happens? When current in the solenoid is changing, flux linked with the solenoid is changing, then induced EMI by dollar. Okay now what is the total flux? Linked with the solenoid. How can I calculate flux? So then total flux means actually the solenoid having n turns. Flux linked with the each turn is 5. The total flux is n into 5. So flux is the dot product of n value as it is the dot product of B bar dot E. Correct? Magnetic field induction and area vector. So what is the direction of the magnetic field when I consider a solenoid? I will write the diagram here. Magnetic field due to the solenoid will be along its axis. Then if I draw the normal to this circular cross section, so that is the direction of A bar. A bar and B bar both are in the same direction. If I consider this surface, normal will be like this. That time A bar and B cap perpendicular. There is no flux due to curvature. Flux is only linked with the circular cross section. So for circular cross section, B bar and A bar both are in the same direction. Then I will get n into 5 value is equal to n value B into A cos 0 1. So n into phi value is equal to n value can write n into L. Small n is equal to n by L. So capital N value is equal to n into L. So from this n into L into B into E. But what is B value? Magnetic field due to a solenoid. So due to a solenoid we derived the expression for magnetic field. But so B value inside the solenoid is given by mu naught into n into I. This magnetic field is not uniform. When this magnetic field is uniform, if so L value greater than R, so B is uniform. We can neglect the edge effect. The magnetic field is uniform. So what is the magnetic field inside the solenoid? Mu naught into n into I. If I substitute here, so what I get? N into phi value, n into phi value, n into L into B value mu naught into n into I into this one A value pi r square. What is the area? Pi r square. So what I get? N into phi value will be equal to mu naught into n square into so pi r square into L into I. Can I call equation 1? Very simple method. This is only the same method we followed for mutual induction. To get the clarity of the mutual induction, if you listen the today class is related with the last class also. If you listen the today class properly, then you will get complete clarity regarding the last class also. Okay na? So now, but we know that, but the total flux linked with the solenoid is directly proportional to current passing. Just now we discussed. Total flux is directly proportional to current passing. So then n into phi will be equal to L into I. Can I call equation 2? So comparing these equations, comparing equations 1 and 2. Equations 1 and 2. Then what I get? L value is equal to mu naught into n square into pi into r square into. So this is the expression for which one? The self-inductance of a long current carrying solenoid. But remember, this solenoid can be air core solenoid. Air core in the solenoid in the sense the turns are wounded on air itself. Whenever it is a air core solenoid, then we will write L is equal to this one. If it is wounded on a medium, so mu into n square into pi into r square into. For the medium other than air, then L value mu r into mu naught into n square into pi into r square into. When I write mu, when I write mu naught. The medium, which is the medium? Here the medium was there. The air core means like this. It will be wounded on air. So okay now, but sometimes it is not every time air core. If it is wounded on any other material, that material permeability is mu or relative permeability is mu r, then we will write this. Are you getting r? So this is the one. The last point is on what factors the self-inductance of a solenoid depends. What is the formula for L we got? L is equal to mu r into mu naught into so mu r into mu naught into n square into pi into r square into. So L depends upon the self-inductance of a solenoid. It depends upon the factors. So geometry of the coils. It depends upon the geometry of the coils. What is the meaning of geometry? Length, radius, number of turns. And it depends upon the medium. What is the medium on which the solenoid is wounded? So these are the factors on which L value depends. So last one more topic, that is expression for energy stored in a coil. To make the current to flow, so against this induced EMF, we need to do some work. The work done will store in the form of potential energy. Expression for energy stored in a coil. Then we will discuss AC generator. So that 2 topics are left. So tomorrow class we will finish that. Okay now? Okay, thank you.